In this video, I will talk about some basics in relation to educational assessment. This is primarily from a formal learning perspective and intended to give you an overarching understanding of the subject. You will then get to read texts that connect this to games. Like in some of the previous videos with an educational focus, there will be a lot of specific language and phrases. You are not supposed to know them by heart. But to present academic concepts and then not tell you what they are called seems not very relevant in an academic class. It can also be good to have heard them, so you have a chance of recognizing them if you run into them again. So let's start out with talking about why do we assess? Assessment is a big part of formal education and many times also relevant for non-formal education. This means that if we want to work with games and learning, we also need to think about assessment. But why do we assess? What is the reason? Paul Newton has made a pretty extensive list that highlights some of the reasons. Let's go through it to get an idea about what it can be, and then we will go deeper into some of these parts that might be more relevant in relation to a teacher's work in the classroom. So, the first reason to assess: to decide whether students are making sufficient progress in attainment in relation to expectations or targets, and potentially to allocate rewards or sanctions. That is student monitoring. 2. To identify students' proximal learning needs, guiding subsequent teaching, that is formative teaching. We will get back to this and explain it more in detail here later. 3. To judge the social or personal value of students' achievements, that is social evaluation. 4. To clarify the type and extent of students' learning difficulties in light of a well-established criteria, that is diagnosis. To determine whether students meet eligibility criteria for special educational provision, that is provision eligibility. 6. To identify students who differ significantly from their peers for further assessment, that is screening. 7. To segregate students into homogeneous groups on the basis of aptitudes or attainments to make the instructional process more straightforward, that is segregation. 8. To identify the most suitable courses or vocations for students to pursue given their aptitudes. That is guidance. 9. To identify the general educational needs of students who transfer to new schools. That is transfer. 10. To locate students with respect to their position in a specified learning sequence, to identify the level of course which most closely reflects it. So for example, should this student take standard or advanced math? That is placement. 11. To decide whether students are sufficiently qualified for a job, course, or role in life. That is, whether they are equipped to succeed in it and whether to enroll them or to appoint them to it. That is qualification. 12. To predict which students, all of whom might in principle be sufficiently qualified, will be the most successful in a job, course, or role in life, and to select between them. That is selection. 13. To provide legal advice, the license of minimum competence to practice a specialist activity, to warrant stakeholders' trust in the practitioner. That is licensing. Then we have 14, to provide evidence, the certificate of higher competence to practice a specialist activity or a subset thereof to warrant stakeholders' trust in the practitioner. That is certification. 15. To identify the most desirable school for a child to attend. School choice. 16. To decide whether institutional performance relating to individual teachers, classes, or schools is rising or falling in relation to expectations or targets, and potentially to allocate rewards or sanctions. That is institution monitoring. Then we have 17. To identify institutional needs and consequently to allocate resources to them. That is resource allocation. 18. To identify institutional failure and consequently to justify intervention. That is organizational intervention. 19. To evaluate the success of educational programs or initiatives, nationally or locally. That is program evaluation. 20. To decide whether system performance relating to individual regions or the nation is rising or falling in relation to expectations or targets, and potentially to allocate rewards or sanctions. That is system monitoring. 21. To guide decisions on comparability of examination standards for later assessment on the basis of cohort performance in earlier ones. That is comparability. And number 22, to quality adjust education output indicators. That is national accounting. So, as you can see, there are loads of different reasons for assessment on many different levels. So now let's take a closer look at some of the parts relevant in the classroom. And here we have 3 ways to think about assessment in relation to learning. We have assessment of learning. That is sometimes called summative learning. We have assessment for learning. That is formative. And then we have assessment as learning. That is metacognitive. So we're going to go a bit deeper into these ones. Let's start with summative assessment. Assessment of learning. So this is done to give the teacher and the students information about what knowledge level they have reached. It's about summing up the knowledge. So this is usually done at the end of a course, program, or unit of work. So the classic example is a written exam at the end of a course marked by a teacher, but it could also be that the teacher set and mark coursework portfolios or externally set and marked exams. So this is about establishing the student's knowledge level at this point in time. Then we have formative assessment, assessment for learning. So this is done to guide the teacher on how to plan or improve the teaching and to help students improve their learning. It's about forming the educational process. So formative tests many times aren't even graded, and therefore they also give less pressure. This is usually done before or during a course, program, or unit of work, and it's often done more than once. And the 3 processes in formative assessment are establishing where the students are going, and what needs to be done to get them there. Then we have the metacognitive, the assessment as learning. So metacognition in relation to learning is sometimes talked about as the learning how to learn. It's about an intentional and planned process. In relation to assessment, this means that the students should do self and peer assessments and then decide what their next learning will be, while the teacher here would be more of a guide on the side. The difference compared to the other ones is that here the students actually have an active role. And this is done regularly, like it's an ongoing process that you keep doing all the time. Here you are also trying to answer the same questions as in formative assessment, but you ask them for yourself. So the three processes are then becoming: where am I right now? Where am I going? And what can I do to get there? The teacher in formal assessment is focused both on the general level for the whole class and also on the individual students. The student doing metacognitive assessment is focused only on the individual level. So the teacher might ask themselves if they should do an extra lecture on a certain part of a topic that the student seems to struggle with, while a student might ask themselves what they have tried to solve this math problem, maybe reading the example, and what other things they could try that they haven't done yet, maybe ask a peer or ask the teacher, or try to solve the example without looking at the explanation and see where they go wrong, or maybe try another problem first. Sometimes when not separating between the students and the teacher's roles as clearly as I have done here, then you talk about like this whole metacognitive as learning. That is seen as a part of formative assessment, since it is also focused on how to improve the learning. So sometimes that goes in there. What is important to note here is that all types of evaluations, no matter if it's multi-choice tests, portfolios, oral presentations, or any other, can be used for both formative, summative, or metacognitive purposes, even if the evaluations might look different depending on the purpose. So let's talk a bit about transparency. Should the students actually know? Should the students know exactly what tasks they are being graded on? This might seem like an easy question, but it's actually harder than one might think. Some risks that can come with being transparent with what specific tasks or tests that you base the grade on includes that you might get students that are studying just for the test and not for learning the content. And if a student knows they are only graded on some specific task, they might not want to do the formative tasks or tests because they don't get graded on that part anyway, so what's the point? Some students also have a hard time showing their knowledge in specific high-pressure situations like a test. And as a teacher, you might see that your student has a lot of knowledge about this subject, even if they don't really are able to show it at a specific summative evaluation. But if you said you will only base the grade on a summative test, then can you really use that knowledge when you're grading? And how will that affect the other students? On the other hand, there are risks with not being transparent also. If the students don't know what they are being graded on, it's sometimes hard to know what to focus on. If you, as a teacher, weigh in on everything the students do during a course, then that can lead to the students always feeling assessed and not daring to fail. And failing is super important for learning. From a formative perspective, finding the knowledge gaps is one of the most important parts to know to help improve learning. And this is a balance, and different school systems also handle this in different ways. How to compare results. There are two ways we usually talk about how you can compare results. We have the norm-related way. That is when you compare your students' results to a student norm group's general results. And then you see if they did better or worse than the other group, and place the students on a bell curve. The group, in this case, that you relate them to can be maybe this class, this school, that's on a more local level, a regional one, a national one, and in a few cases also on an international level. But this can only be used for standardized tests. And a standardized test is a test that is carefully designed for consistency of format, content, and administration procedure based on statistical evidence. And this relates to validity and reliability. That is something we will talk about here later. The other way is to do criteria related. Here you do not compare the student to other students, but instead you compare to specific learning goals or previously given criteria. So criteria-related results measure to what level specific learning goals have been achieved. So here it doesn't matter how the other students did. Everyone can fail or everyone can get the highest grade. It doesn't matter if you were better than all your classmates if none of you reached the level needed to pass. And this is what we use here in this course. And there are also occasions where you want the students, for example, to have 100% to be able to pass. So you have to have everything right to be able to pass. And that goes for every single student. I mean, you wouldn't want a heart surgery from a doctor who only makes a wrong cut 10% of the time. That wouldn't be great. Criteria-related tests can be arbitrary. It might be hard to motivate why a student got 17 that got 17 out of 20 on a test should pass, but not the student that got 16 out of 20. And talking about test results, one of the issues with test results is that the results are often misinterpreted. There is no test that will give a perfect answer to a student's knowledge level. When it comes to creating tests and interpreting test results, there are 3 parts that are really important that we will talk about here. Those are validity, reliability, and fairness. Let's start with validity. Validity refers to the degree to which evidence and theory support the interpretations of test scores for proposed uses of tests. AKA, do we measure what we want to measure? So say you get to read a list of words, and right after you get a test where you are supposed to write those words down to see if you have learned them. What are you actually measuring here? Are you measuring if I learn the words, or are you actually just measuring my short-term memory? To ease discussion, validity is often described as 2 different types. You have content-related validity and criterion-related validity. And we're going to go into those a little bit here. So content-related validity. How well do the items in the test cover the appropriate content? And this can be split into phase validity. Does the test appear to test what it aims to test? So how well does the test represent what was included in the curriculum? So let's say I would like to test if the students learned about the different learning theories. But then I only ask questions about behaviorism on the test. Then I have low validity. If I, on the other hand, want to test the student's knowledge on behaviorism and use the same test, then maybe it actually has high validity. Then we have construct validity, and that concerns how well a set of indicators represent or reflect a concept that is not directly measurable. So this is actually more of a concern in, for example, psychologically focused tests. So it's more relevant for things like measuring motivation, readiness to move on, mental ability, attitudes, and so on, that are not like clearly measurable in the same way. And that is usually not as relevant for teachers. So usually for teachers, when talking about validity, you're talking about face validity. Then we have criterion-related validity. So this is relationship to other measures, where the first part of this is predictive validity. So how well does a test predict a criterion? You do a test to get into college. And this test is supposed to predict which students will be able to make it through college and how well they will do. Then this needs to be compared to the criterion, aka how well did it actually go for the students. Another example of this is the pre-employment tests you sometimes get to do. Do they actually predict your productivity as an employee? Do they have a good predictive validity? The other type here is concurrent validity. That is the extent to which the results of a particular test or instrument corresponds to those of a previously established test or instrument for the same construct. So for example, let's say I'm going to make a new shorter test on the same content like I have an older standardized test that I know have good validity. Then the test scores that my students get must differentiate between the individuals in the same way on both tests. If that relationship is in any way inconsistent or weak, then the new test does not demonstrate concurrent validity. So when talking about validity, it's important to understand that validity is not a property of a test or an assessment, but to the interference made on the basis of scores. So there, you really shouldn't say that this is a valid test, because like we talked about, it could be valid in one situation and not in another. So it's not something a test just are. Validity is always related to context and the purpose of the assessment. Does the assessment measure what it intends to? Is the assessment fit for that purpose? Validity also relates to how test scores are used. Are the results of an assessment interpreted and used appropriately? And what are the social consequences? Now we're moving on to reliability. Okay, so validity told us if we are measuring the right thing. Reliability, on the other hand, tells us how well we measure that thing. So it's about consistency and repeatability. How reliable are the tests? And there are different forms of reliability evidence. For example, test-retest. That is about consistency over time. So if a large group of students take a test many times and they get the same relative results, then it's probably reliable. If then, of course, the students didn't study more between the tests or got results in between, because then, of course, the results within the group can change because of those factors. Then we have inter-rater reliability, and that is consistency over raters. So will two teachers grading the same test give the same grade? Then we have parallel forms of reliability evidence. So that is about consistency over test forms. So this is a bit like concurrent validity that we talked about before, but for reliability. So let's say your students will get to take the same multi-choice test more than once, and you don't want them to just memorize the answers in a specific order. So you don't want them to go 1B, 2C, 3B, and just memorize that. This means you can't use exactly the same test twice, but you still want the test to be consistent. Then you can do things like rearrange the order of the questions, changing the wording in some of the questions a bit, or adding new questions for the same kind of data to make sure that they actually answer right also on the new ones. Then we have internal consistency. That is consistency over test items. So this concerns how well the items, that is the individual questions on a test, function in a consistent way. And this can be calculated after only one test administrations, unlike all the other forms we have talked about here. So for example, you compare the results on half of the test questions with the other half. If a student got really good answer on all the odd number questions, but not on the even ones, then it seems like the questions might not be very consistent. And this is one way of doing this that is called split half reliability. Another way it's often done is by using Cronbach's alpha, and sometimes you use a combination of these. And we won't go into exactly how to do those calculations here, but if you are interested and want to go through a test you have done to look into this, then you know what to search for. When it comes to internal consistency, the more test items you can have on the same thing, the more reliable the results will be, up to a certain point where you don't really get much more information. Then there can be other reasons that it's not doable to have super long tests with loads of questions on every single thing. So you instead go for a lower reliability. Now we're going to talk about the standard error of measurement. Because what a student gets as a result at a test is probably not their true score. All test results will have a certain margin of error that doesn't give information about the student's actual knowledge level. Maybe the student was sick, maybe they didn't get enough time, or some of the test questions were really unclear. So the observed score that we see is the true score of the student plus minus the error. And the error can be systematic or it can be random. So systematic would be you have written the questions in an unclear way. That is in the system. And random could be I am sick today, so I don't do good. That's very random. And the cool thing here is that all of this can be accounted for in statistics. So the standard error of measurement is how much a measured test scores are spread around a true score. So how many points over or under a student would get of their true score. And many standardized tests have calculated standard error of measurement that shows how large part of the student's results is likely to vary if the test was done many times. So a test that has a high reliability usually has a low standard error of measurement because you can then account for some of the more standardized problems. So SEM is a standard error of measurement. SEM is a good reminder that individual students' test scores are actually quite imprecise. Now let's talk about a confidence interval. So this is a range of values where an individual student's score is likely to be. So let's say we have a test that tells us that it has a standard error of measurement of 5. And student A gets 70 points on their test. And we now know that their observed score aka 70 points, is their true score plus minus the error. And we then know that the SEM is 5. So here we can see that their true score, 70 plus minus 5, means somewhere between 65 and 75. This is what we call the confidence interval. So somewhere here will the student's true score be. We will never know exactly where, but somewhere between here. So let's add another student, student B, and they get 77 points on the same test, and therefore have a confidence interval between 72 and 83. So here you can see that I have drawn out both students. Student B is at the bottom. I haven't put in the numbers on the lines because that was hard because of space issues, but I think you get the idea. So you have student A in the middle and student B at the bottom. So at a first glance, you might say, okay, so student A got 70 points and student B got 77. Like 7-point in difference, that is actually quite a lot. But what you can see here is that the students' confidence intervals are actually overlapping. So let's put them on the same line to try to make this clear. So here you can see. So what we can see here is that both of them might have 74 in the middle here as their true score. Or maybe student A, that is more to the left here, actually has a higher true score than student B. This must be considered when giving students a grade. Because if you then need 73 points to pass the class, you might actually pass a student that should fail, or the other way around. And this is why giving a grade based on only one test becomes problematic. This also means that the more different grades you have on a scale, like if you have a 1 to 10 scale or a A to E instead of just pass-fail, the higher the chance will become that a student will get a wrong grade. Because the intervals between the grades become smaller as you have more grades. I mean, if you're gonna, from 73 here and up to the right are supposed to get in 10 different grades instead of 2, they will be closer together. And that means that it's likelier that the student's confidence interval will cross over a grade cutoff point. Okay, we talked about validity and we talked about reliability, but how do they relate to each other? So here you can see I've done some dartboards. So the closer to the center the darts are, the more valid the results are. And the darts' relative position to each other indicate reliability. So the closer clustered together they are, the more reliable. So the first board shows an example of when we are measuring the right thing, validity, and doing it with very well with a high precision, that is reliability. So we have high validity and high reliability. In the second board, we have high reliability but low validity. So this is like the example we had when we talked about when we wanted to measure how well you would learn words quickly, but you were actually measuring their short-term memory. So the results might be super specific and the same over time or depending on who is grading it, but they are not measuring the right thing. So they are not hitting the center of the board. And in the last one, we have low reliability, and that means we can't have high validity. At least not for the context we are talking about here in schools related to grading. There are other statistical uses where this works in a different way, but we are not going to get into all of that here. So, for example, let's say we have 4 different teachers that grade the same test from a student, and they all give the student different grades. Then the result is not reliable, since it's so spread out. It isn't consistent. But this also means we can't say that the test clearly measures the right thing, because all the teachers gave different grades, so we don't really know, and therefore validity is also low. So you can have high reliability with low validity, but not low reliability and high validity when it comes to this type of situation. The more important and high stakes a test is, then the more important validity and reliability becomes. So if it is you have one shot to do this test, then you better make sure it's a good test. Now we're going to talk a bit about fairness. And here we talk about absence of bias. So that is systematic issues that affect the result. So this is things like content, language, examples in a test. So there are different forms of assessment bias. You have offensiveness, and that occurs when negative stereotypes of a certain subgroup are presented in a test. This can distract students. Then you have unfair penalization, and that occurs when a student's test performance is distorted because the content of a test disadvantages a student because of their group membership. The content of a test does not give all students group an equal chance to perform well. So for example, if you have a test with content that will be understood differently by children growing up in a city versus if they grew up in a rural community. So the question, describe the field where your parents work, can get a very different answer depending on if your parents are academics or if they are farmers. Or if you have a test question that relates to sports that are very gendered, like for example today maybe boxing or ballet, then the test could be seen as biased. This leads us to standardization. This has typically been considered one of the most important requirements to defend fair and accurate assessment, keeping everything the same for everyone. But that also has its problems, because what does that mean? Everyone might get to take the same written exam, but will everyone have the same chance to show their knowledge? Is it equal for all? What happens if one student has dyslexia, for example? Is it really fair and equal then? And this leads us to accommodations. So changing the testing conditions in a way that improves fairness, but without undermining the main point of the assessment. Making testing conditions more flexible, maybe not just for some students, but for everyone. So to summarize a bit, we have now talked about the reason that we have assessments, and there are loads of them. And we have talked about ways to assess in relation to learning. We have talked about assessment of learning, summative, for learning, formative, and as learning, metacognitive. As Robert Stake put it, when the cook tastes the soup, it is formative, but when the guest tastes the soup, it is summative. We went through what is important for creating tests and interpreting the results. And here we talked about validity, how valid our tests are. Are you testing the right thing? And reliability, how reliable our tests are. Are they testing the same thing every time, and how well does it measure what we want to measure? In relation to this, we talked about standard error of measurement, SEM. We talked about how the observed score is the true score plus minus the error, and the error can be systematic or random. We talked about confidence interval. How big is the interval of this error? And we also talked about how validity and reliability relate to each other. In the end, we mentioned fairness and absence of bias and systematic issues that affects the results. And this was it for this time. So thank you for listening, and I'll see you around in the next video.